Hi Chem 20s, Miss Riley here. Another Chem 20 video for you. It's my third time trying to make this video, so hopefully it works. We are talking about limiting and excess reagent stoichiometry. We're going to look at the topic of how do I determine the limiting reagent in a chemical reaction. And just for a little review, the limiting reagent is the reactant that's going to get completely used up in a chemical reaction. So every chemical reaction, you're going to have something that gets completely used up. That's your limiting reagent. And you're going to have a reactant that there's some extra of. That's your excess reagent. Now it's your limiting reagent that determines how much of the products that you can make. Because once it's used up, you can't make any more products. So I'm going to show you guys two ways of thinking about limiting and excess reagents. Okay, so first one, I'm going to use a model, and then we're going to use some math and stoichiometry. So here's a practice question for us. So if I react 3 moles of hydrogen gas with 2 moles of oxygen gas to produce water, what is the limiting reagent in this equation? So a little hint for you guys, if I'm giving you the amounts of both reactants, it's a limiting excess stoichiometry question. You're going to have to figure out which one's the limiting, and then sometimes you need to do something with that. And so we want to figure out what is the limiting reagent, or which reactant would produce the least or limit the amount of product. So I'm going to show you with a model here. So I have my balanced chemical equation here. I'm going to write down my given information. My question is telling me I have 3 moles of hydrogen gas, and I'm going to react that with 2 moles of oxygen gas. And I want to figure out which of these is going to get used up and which is there going to be extra of when I combine them to make water. So I'm going to use a little model here. So if you guys look on the left, I have hydrogen as green and oxygen as pink. So if I have 3 moles of H2, I have 3 H2s. Okay, so each green block represents a hydrogen atom. I have 3 H2s here. And then I have, get my pink, I have 2 moles or 2 helpings of O2. So I have 1 O2, 2 O2s. So I have 4 oxygen atoms that I'm going to react here, or I guess I shouldn't call them atoms, but you guys get the picture. Okay, I got this many, moles. So now how much water can I produce from this? Okay, so well, to make a water, I need 2 hydrogens and 1 oxygen. Okay, so I'm going to take 2 hydrogens, okay, and 1 oxygen. Okay, and I'm going to make a water. Great. Okay, let's do that again. I'm going to use 2 hydrogens and 1 oxygen. So there's another water. And then I'm going to grab 2 more hydrogens and 1 more oxygen. And okay, can I make any more? No, the hydrogen is all used up. The hydrogen here is my limiting reagent. Okay, the oxygen is my excess. I have 1 mole of oxygen left here, so this is my excess reagent. The hydrogen limited how much of my product that I could produce. Okay, so that's a way of looking at it with a model, and hopefully that helps you guys understand the concept of a limiting reagent. And so let's look at a mathematical problem and how we would do this. So there's a couple different ways to attack these mathematically. I'm going to give you these steps. These are from your notes package for my Chem 20s. Step 1, you want to write and balance a chemical equation. With any stoichiometry, you need a balanced chemical equation. Step 2, you need to determine the number of moles of each starting material. This is the first step in stoichiometry. Well, I guess the second step in stoichiometry. You always need to find the number of moles of your given. So in this case, you want to find the number of moles of each starting material. Okay. The third step, you're going to use the molar ratio to figure out, to make 1 mole of product, how many moles of that reactant am I gonna need? So the way you can do that is you can actually just divide the moles of each starting material by that chemical's coefficient in the balanced equation. Okay, so sort of a little shortcut. The smallest number that comes out of there is going to tell you what your limiting reagent is. So let's do a problem. This is number 2 from the problems in my Chem 20s workbook. And so let's do this. So we need a balanced chemical equation here, but let's look at the problem. If 1 kilogram of glucose, and we're told here that's equal to 5.55 moles, is reacted with 34 moles of oxygen during the process of cellular respiration, which reactant is limiting? Cellular respiration, kids, you should know this, my Chem 20s. Glucose, C6H12O6, one of the first chemical compounds you learn, is reacted with 34 moles of oxygen. So we just got to get my O2 here. And from that, we're going to produce, what do we produce again here, kids? Oh yeah, we produce carbon dioxide. Okay, this is like a combustion reaction. And we produce water vapor. And we also, it's an exothermic release of energy in this one. Let's put liquid here. Okay, now I need to balance this equation. I'm going to need 6 CO2s. Okay, I'm going to need 6 waters, and then I'm going to also need I think 6 more oxygens here. So I have 6 carbons on both sides. I have 12 hydrogens on both sides. On my product side, I have 6 plus 12. I have 18 oxygens. On my reactant side, I have 12 plus 6, I have 18 oxygens. So I'm balanced. You guys probably recognize that chemical equation. Okay, so I'm going to write down my given information. I have 34 moles of oxygen, and I have 5.55 moles of glucose. Now, I'm not going to draw those models for 34 moles of oxygen, so I'm going to use math. Okay, so for each of these reactants, I'm going to find the number of moles. I already have them. And then I'm going to divide that number by the chemical coefficient. So let's do it for glucose. So I have 5.55 moles of C6H12O6, and I'm going to divide that by the coefficient. I could write it like this. I'd say, okay, well, I have 1 mole of C6H12O6, and I'll just put a placeholder up there. I could also, if I know which product that I'm looking for, I can put the coefficient of my product up there, right? If I want to find that, that'll go on top. But for now, I can just do this and get a value. So obviously this is just going to give me 5.55. And my oxygen, so I have 34.0 moles of oxygen, and I'm going to divide that by my coefficient from my chemical equation. So I have a 6 here. So I have 6 moles of oxygen, and so 34 divided by 6 is 5 point, oh man, it would seem smarter than that, but I don't know. 34 divided by 6 is 5.6 repeating, so 5.67 we'll say. And so to make 1 mole of product, I'm going to need 5.67 moles of oxygen and 5.5 moles of glucose. So glucose is going to get used up, and oxygen, there's going to be some extra. So the lower number here is going to tell me that glucose is my limiting reagent. That's going to get completely used up. Now, I could, from here, say, okay, I know glucose is my limiting reagent. how much carbon dioxide will be produced, or how much water will be produced. Or I could even say, well, how much oxygen are you actually going to need? And I could ask you, you know, how much oxygen is going to be left over. And so there's there's a lot of different ways that we could go with this. That's the basic. I'm going to make a more advanced video for the next one. Okay, hope that helps, guys.